Hello, and welcome to Voices of the Industry, a podcast series bringing you leading industry voices who challenge thinking across transportation, infrastructure, and cities. Hello, and welcome to Voices of the Industry, a STEER podcast. Digital infrastructure could soon transform the way highways across the US are maintained and used. And the birthplace of this digital highway revolution will appropriately be the home of the US automotive industry, Michigan. A connected and automated vehicle corridor, or CAV corridor, will soon be operational across I-94 in southeast Michigan, connecting the thriving university town of Ann Arbor with Michigan's long-standing manufacturing hub, Detroit. This first-of-its-kind smart road deployment is being developed by Cavnue, a company that designs physical and digital infrastructure to enable the safe, efficient, and automated transportation of people and goods. Cavnue has partnered with the Michigan Department of Transportation to deliver the US's first CAV corridor. With me today to discuss this exciting development for North American roads is Megan Brock, Senior Strategy Manager at Cavnue. Megan has been with Cavnue for 3 years, where she works on quantifying the value of Cavnue's project to the wider ecosystem of road stakeholders, from road users to OEMs to departments of transportation. Prior to joining Cavnue, Megan worked on demand modelling, business case, and impact analysis with STEER over the course of 7 years. Hello, Megan.
Hello, it's great to be here. Thank you for that intro, Tim.
No problem. I was wondering, since I know that people drive a lot in the US, when did you get your driver's license?
Oh, I got my driver's license when I was 16, I think the earliest you could get it. I did not grow up in a transit-friendly place, so that was how I got around while it's driving.
That was kind of what I was going to ask. Yeah, so I guess, how do you think that this kind of like CAV corridor technology would improve things for young drivers in those kind of areas?
We'll talk a little bit more about what we mean by a CAV corridor shortly, but for young drivers today, driving is one of the most dangerous things that young people can do. CAV corridors really are about giving guidance to drivers about how to navigate roadway risks. And so especially for young drivers, I think that's important. And there's a lot of research about particularly how young drivers respond to information incentives about how to travel more safely and efficiently. And so I think CAV corridors can support that.
Road safety concerns. Is that like a big concern for everyday Americans, Megan?
Well, road safety is a national crisis in this country. We have over 40,000 road fatalities occurring here a year and countless more injury and damage producing crashes. So, people face real risk when they get in their cars, and it's a real challenge the industry is universally focused on.
That's great. Thank you. Also joining us is STEER associate Toni Feather. Toni is part of our North American infrastructure team. She has worked at STEER for over 15 years, focusing on forecasting demand and revenue to support investors in transport infrastructure. A lot of Toni's experience and interest is in understanding and predicting behavioural responses to changes in transportation. This has included estimating the response to the introduction of a hyperloop in India, toll roads in South Africa, high-speed rail in the US, and most recently, CAV corridors in Michigan. Welcome, Toni.
Thanks, Tim. Hi.
That was kind of an impressive list of projects that I just reeled off. I wonder if you have a favourite thing that you've worked on while you've been at STEER. I know it's been a long time.
I think I go through phases, to be honest. It's always the ones that are the kind of more at the forefront of my mind that are the ones that stick, I guess. So I think the Hyperloop one was really interesting because it was very different and it was in India, but 1 year in it got kind of cancelled. The government didn't follow that, so then it became nothing. So that's not as exciting. It's also exciting when you have projects that you work on and then they come through and they happen. I think this project with Cavnue is one where, we can see things happening on the ground and press releases, and becomes a lot more of a real, tangible thing that we're studying. So yeah, a huge range basically, but anything that is not that ordinary and means you have to think a bit differently is what I've enjoyed.
Yeah, I guess like from your mind to the real world must make you feel very powerful.
Yeah, it's a bit scary as well. But yeah, I can take the powerful.
Nice. Thank you. Well, welcome both. Right, so Megan, I've given a brief description at the beginning there of CAV corridors, but could you maybe tell us a little bit more about what Cavnue is and what you're working on?
Yeah, of course. Well, so Cavnue is building smart roads, starting with our flagship project in Michigan, which we'll get into more. But foundational to our projects is continuous roadway coverage, meaning we deploy technology poles fit with a sensor pod, compute pod, communications technology that basically enables complete understanding of what's happening on the road, every inch of it. And with that understanding, we can identify emerging roadway risks and deliver guidance to drivers, road operators, and eventually vehicles about how to navigate the road. And we're doing this because we see persistent challenges in road performance and a wave of advanced vehicles entering the market. They're growing in the market. They're here already. When we see that crashes and congestion are growing despite massive investments in roads and vehicles, we start looking for what's going to deliver the next step change in road performance. And since the highway system was built, there's been this growing acknowledgement that digital infrastructure has a role to play. Intelligent transportation systems are known to be highly effective in reducing crashes, congestion, and emissions, but they've been limited by the capabilities of technology and the scope of their deployment. But now we've made this massive investment in roadside and vehicle connectivity, and we have the ability to process just so much more information than we did, 10 years ago, or even imagined 10 years ago, right? And so we, with full coverage, like I said, which is foundational to our projects, we can start to have an awareness of everything that's happening on the road and build predictive insights around that awareness and start to deliver guidance to drivers. So that means we have not only the opportunity to address these persistent road challenges, but equip roads with technology for the advanced vehicles coming onto them. I think brings us to Michigan, where we have our flagship project.
That was great. Thank you. So, and really interesting to hear about the road safety concerns. So yeah, why don't you tell us a little bit more about the I-94 project and how it operates?
Yeah, so we have a 3-mile pilot on 94 live now, part of a broader deployment between Ann Arbor and Detroit. On that 3-mile stretch, we've upgraded the pavement, lighting, guardrail, and delineation, so it looks like an express lane if you've ever been in one of those. And it feels like that. We've upgraded the pavement so it's smooth and no potholes or lane markings are all clear and everything. And we've added the technology poles that I described every 200 meters. So we have a full field of view of what's happening on the road. And that technology offers lane level understanding of road hazards, events, traffic. And right now, our models are training to be able to quickly and precisely understand what's happening on the roads, exactly where it's happening. So that might be hazards like stalled vehicles or debris or vulnerable road users. And these insights that we're building are going to translate into guidance for, like I said, drivers, vehicles, operators to take more proactive actions to be safer, more efficient, and ultimately with automated driving.
That's great. So you kind of ended on automated driving there. Don't know if this is going to be skipping ahead a little bit, but I thought there will surely be a gap between some automation and complete automation. So how will that kind of transition work, and is managing that transition part of the corridor?
Yeah, well, I mean, I think, like I said, there's this wave of advanced vehicles coming in the market already, right? And I think where road operators get concerned is about, we can imagine a completely automated future, and we can imagine now and what's happening in between is where I think roadway complexity will increase. And so having the single source of truth about what's happening on the road and being able to deliver guidance from a single source of truth to every road user, I think will help us navigate that transition period. It takes a long time for vehicle technology to fully roll over. So it will be a long time before, if ever, a fully automated future. So the CAV corridor, like I said, right now we're just building our insights about what's happening on the road. Ultimately, the project will convert into a dedicated lane for connected and advanced vehicles. And the way that I think about that is that allows early realization of that full automated future. So things like coordinated driving, which really maximize the throughput of capacity, improve safety, all these benefits that we expect to realize in that fully automated future, we can get it earlier by concentrating vehicles in a lane, and we can learn a lot from that. So I think I answered your question too.
Yeah. And I also gave more of an insight in terms of how, as well as being an early rollout, it can act as a sort of like early data gathering exercise, I guess, because it's such a smaller thing. Toni, I can see that you're nodding. I don't know if you have anything to add about that and how useful it might be for companies like Steer, especially.
Yeah, they're just nodding away, really. I think the point that Megan made about people being able to envisage the very far off future of everyone automated versus now, that middle bit, as Megan said, it's not going to be a few years. It's going to be over a long period. And it really is the bit that is the most complex and is going to need a lot of input from different stakeholders and public, private. Yeah, I think there's a lot of opportunities to really think how to do that efficiently and as quickly as possible. But knowing that it's going to be a long, methodical process rather than, waking up tomorrow and the roadways will have changed.
Yeah, it seems kind of very close and very far away all at the same time, now that we're having this conversation at least. Okay, so considering how the CAV corridor will be an improvement to how the highway currently works, I wonder if you could maybe tell us a bit about some specifics. I know we just touched on them in the opening and how the technology will improve the conditions for road users. Sure.
The way I think about this is so much of our safety, congestion, and reliability challenges are intertwined. I think if you drive, I think you will have experienced driving down a high-speed roadway and all of a sudden having to slam on the brakes because there's a traffic jam you weren't aware of. And in these moments, we face not only a real risk of a crash or a rear end or something dangerous, but we also thought we were 5 minutes away from where we were going. And we see, even if we have maps on, we see the time ticking up and up and up and up. So our technology will allow drivers to be aware of these events before approaching them. And so we can extend the driver or the vehicle's response and planning time so they can brake sooner or they can reroute. And these proactive actions have a real impact on roadway performance. Studies have shown that a really small proportion of vehicles responding to speed guidance coming through a speed reduction zone, so if everyone slows down just a little bit earlier, can reduce the impact of that jam. It can actually slow the full, when you get to a full stop, it can slow that. It can prolong the time where we're moving forward, and that creates real efficiency benefits for everybody. And so we're trying to affect safety, reliability, congestion just by knowing what's happening on the roads and being able to deliver guidance around that. And I think what's important for our projects is that guidance comes from a single source of truth about what's happening. The events that happen, especially on high-speed roads, they're not static. Debris flies around roads, traffic jams move, right? And so by having a single source of truth about what, exactly where, exactly what, we can deliver really specific guidance to anybody on the road about how to navigate those things, improving their safety, travel times, and reliability. And if I go back to my early illustration about having to slam on the brakes, if you've ever experienced that kind of situation while you have adaptive cruise control, which kind of helps you navigate slowdowns in traffic, you can start to understand why that guidance would be useful to advanced vehicles that are already here, because the planning is important not only for drivers, but for vehicles which are managing stop and start or supporting you in stop and start traffic flow. So that's to drivers and vehicles. On the operational side, there's a whole host of inefficiencies that we would think don't exist on roads today, but they do. And like I said, that's because roadway events are dynamic. Just thinking about I was driving to work the other day and there was a car stalled in the right lane on the freeway and a tow truck moving in. And a dynamic message sign had said, right lane's blocked, Well, as I drove by it, the tow truck moved the vehicle into the shoulder. And so now the right lane's not blocked, which if you knew exactly what was happening, you could change that information really quickly. And that just doesn't happen as much on roads because we don't have that insight. And with full understanding, I think the operations and maintenance tasks will get a lot better, more proactive, faster, and safer for people.
So a phrase that you've used a couple of times that I maybe want to try and unpack is a single source of truth. So what does that mean?
Yeah, well, a lot of the information off roads now is crowdsourced, right? So I don't use Waze, but at one point when I was using Waze, it was like, is that crash still here? And I would have to click when I was driving. Yes, it's still here. Or no, it's not still there. And so everyone's responding to that little prompt differently. Some crowdsourced data comes from vehicles themselves, right? But what's happening is there's all this sort of individual information being gathered about the roads. I actually heard someone else describe this in a useful way, I thought. Traffic jams, like we think they're static because we hit them in one place and then we stop, but they're actually moving backwards. Like it's like a shock wave when a traffic jam happens. And you'll notice if you have like a mapping software that has like the colors about where you're going to hit red, which is like stop, it's almost never accurate to like where you actually hit red, where you have to stop, because it's a moving thing. So there's always going to be some delay with crowdsourced data, be it from drivers or vehicle, to where the jam actually is. And that's what we have now is crowdsourced data. There are cameras on roads, like there's CCTV cameras, but they're sparse, right? And so what our sensors will do will give you one view, like one source about where everything is and how quickly traffic jams are moving and where events are on the road. So that's what I mean by single source of truth.
So it gathers, the system will gather all the contemporaneously the information into one thing and then feed it back to the drivers.
Yeah. To drivers or operators.
Okay.
And I guess the really key thing here is that everybody on that corridor has the exact same information. So it's not one person seeing one thing, another person responding in a different way. And also, Megan, because the corridor will have the full picture of the information, I hope what it can do is the thing that really frustrates me is actually be able to do a bit of short-term forecasting and tell you, what will the delays be like in a few minutes' time, not 1 minute ago, which it's what always frustrates me with those red bits on the map. I'm like, why don't you think about where that red bit's going to be when I get there? Not right now. And that because that CAV corridor is completely controlled environment, it will have that ability to really see the full journey.
Yeah, and I think one thing that I probably haven't stressed enough, which is important, is we have lane level understanding of what's happening, which doesn't really exist today, especially on highways. Like, if there's debris in the road and that's causing a jam, you'll see orange or red or whatever on your map, but you don't know until you get there that you shouldn't be in that lane anymore, right? And so those types of predictive, to your point, Toni, predictive, but also very precise guidance about how to navigate, especially these roads that are high speed, right? Because depending on the capacity, the volumes, the capacity in the road at that point, any type of like inefficient movement can really have a serious effect on what happens behind you. And so again, like this, everyone having the same guidance for how to navigate through these situations can hopefully create better environment for everybody.
Yeah, that really makes a lot of sense. And then I guess also might sound obvious, it just improve people's quality of life quite a lot, because I imagine if you're regularly driving and stuck in traffic, it's not good.
Yeah, I think the average driver in the US loses like 50 hours a year to congestion, and giving people time back is such a huge quality of life improvement, to your point, Tim. And doing so like I said, we're stressing safety, like doing so in a safe way.
With regards to the work that Cavnue and Steer have been doing together, can you offer an overview of the project that we worked on?
Yeah, so I'll let Toni speak to some of this as well, but we worked with Steer to develop what I believe is the first planning level study for a CAV corridor in the United States. So that's a traffic and revenue study where we really focused on understanding the value of automated driving to Michigan drivers. So much like any planning level traffic and revenue study, I'll let Toni speak to all the fun stuff about network models and whatnot. But I think what's interesting about this project is that autonomy aspect, about what it means for people to have time back in their vehicle. So if your vehicle's handling the driving task for you, what can you do and how do you value that time? It's different than the time you get, like if you get somewhere earlier, right? So we did a lot of primary research. We surveyed drivers, we reviewed academic studies, and really like grappled with how drivers think about the time they spend in their vehicle and what it might look like to have some of that time back. Toni, do you want to speak to any of that research that we did?
Yeah, we held focus groups to understand how people perceive these corridors. I mean, for us talking today, we've talked about CAV corridors a lot. Megan, it's her whole job talking about this. So for us, it's very familiar. For some people, they're like, what would I be doing and how would that work? And, maybe slightly kind of apprehensive because that's different to how things are now. So, we had to do a lot of work talking with people, understanding how they perceive this and how to really communicate the benefits to get past that initial, oh, this is different, to what it might be like for them and when they could actually use the corridor. And that's a real option for them and in their vehicle. So the first bit was the focus groups. You then needed to design an online survey to really not only get some basic information about their journey, but also try and get them to share with us what Megan was saying, what value they would put on this kind of a corridor. So really trying to give them choices and to ask questions in a way that means that we can estimate how they would value this corridor compared to, say, a normal express lane or, just a normal highway. How much more value it would give them, but equally, would they be prepared to pay for that extra value and how much and how would that work? So a lot of our focus was really in, first of all, working out how to explain this to someone that might not be too aware of it and not overwhelming them. And then really trying to get at, in that situation, how would you value this and what value would you put on these corridors? And then comes the less exciting part where we then have to put all the numbers together and prepare a forecast and really, look at a lot of scenarios to understand what the impact of this corridor would be and who would use it with all of that information that we've got from the primary research.
So how long have we been working on this?
I want to say 2 years.
I think 2 years, yeah.
It's just interesting because you're kind of working with something that essentially doesn't quite exist. Yeah. So, is there a cumulative, or do you expect there to be a cumulative effect of the rollout and the data since we've started? Have you seen maybe even in the time that we've been working with people, have you seen a shift in attitudes?
Well, I find it quite hard to answer this question without being biased because I feel like obviously I have learned a lot more about these corridors and trying to separate that from the average person on the street. I think, like Megan was saying at the beginning, there has been more of a rollout of these vehicles and vehicles that can do more and more for you. So I think there is a bit more of a comfort level for some people of, I let my vehicle park for me or use cruise control, etc. But I think it's probably a lot slower than our knowledge about these things and how much more expertise we have now compared to 2 years ago, compared to the person on the street that may or may not have bought a new vehicle in those 2 years, I would say. I don't know, Megan, do you feel the same in your bubble? It's quite hard to look outside that.
Well, I think that's well said, Toni. For us, we have parts of the I-94 pilot operational now, and for the people that we speak to in the transportation ecosystem, that's huge because it's real and people can start to imagine how they would use it. So we hope that starts to build an understanding. Just having a project live on 94, it's short, it's 3 months, but it's real. And so I think to Toni's point, though, there are layers to this that are atypical for TNR studies because there's a vehicle technology component, which if you don't have a new vehicle, you kind of have to imagine. And then there's that vehicle in the lane, which then is another step of having to imagine. And so I think a lot of the work that Steer did was trying to, first of all, explain in a clear way to the average driver what a CAV corridor will be. And then second of all, trying to sort through the uncertainty in any type of survey about future technology or environment to deliver meaningful insights about what might happen in 5, 10, 30 years. So I think that back to what Toni likes about her work, I think that we ticked some of the boxes for what keeps her, what was it, your brain going?
Yeah, definitely.
So yeah, a really interesting project. And as we get more and more insights from the corridor, that will help improve our understanding of how people will use it and how they might value it.
It's an interesting point that obviously automated vehicles and connected automated vehicles sound so futuristic. I mean, I appreciate probably not to you, Megan, because you're working with it all the time. But actually, when you think about the science of forecasting, if I can call it that, it's another case where you're figuring out just kind of another new thing, even though perhaps it sounds slightly more. Although I guess you worked on the Hyperloop, which also sounds very futuristic.
But to be honest, I mean, lots of our forecasting that we do for investment, it's over decades, sometimes over the next 70 years. So yeah, it's not happening next year, but it's definitely happening in the horizon of investors and the decision making that investors are making. So yeah, it's something we're having to think about more and more. And yeah, there's more and more information and thinking going into what impact CAVs will have. And kind of with two angles. One is the angle of Cavnue really being very proactive and making that investment to give people the opportunities early on. And then the other is that more long horizon where we just wait for the fleet to naturally turn over, and then there will be impacts of having cabs in the vehicle fleet in the much longer term. So we're thinking about both in lots of our TNR studies. This is the one, like Megan said, it's the first one that we're working on, where we're really thinking about what's happening and quite immediate impacts of the investments in CAV infrastructure.
In terms of public, I assume there'll be people buying new cabs, and then there'll be an element where you're waiting for those to filter down into the secondhand market, right? Because most models are secondhand, aren't they? So do you factor in like public take-up of CAVs? Obviously, you must have to at some point, but like, is there just a natural assumption that it will eventually all be CAVs? Or are you thinking some people might purposefully not want to buy them, and that would be a factor in forecasting?
So there's a lot in there, like when new models enter the fleet with what features, and then of course how quickly vehicles without that technology are retired. And through that work, we know that we're going to be in a mixed environment with CAVs and non-CAVs for a really long time. As you get further and further out into a forecast, you are of course confronted with increasing levels of uncertainty. It's hard to say what will happen in 50, 60, 70 years, and Toni knows this quite well, but many people talk about this fully autonomous future. We just don't see that happening in our forecast. We see supply and demand side constraints to reaching the scenario where every car is driving around hands-free. And what we're thinking about is how to maximize the system benefits of these vehicles, given the likely scenario that there are always less advanced vehicles operating alongside them.
What personally for you as a project was insightful, or what was something new that you learned while you were doing it?
Yeah, I guess for me, the really interesting and challenging part of this project has been that bit I was talking about really getting people to think about this future and the average person, what it would mean for them to have a CAV corridor. And I think as often with surveys, you go out thinking, oh yeah, I'll just put this and it will work, but it's never that simple. And people always have their prejudice or previous experience, or, you don't quite explain something in the way of what they're thinking. So as with every survey project I've done, a new round of learnings on how to explain things to people. And, you're explaining something quite complicated. You need to keep it simple, but you also need to be reassuring and not leave too much ambiguity, because then they fill the gap maybe with things that you don't want them to be thinking. So really that challenge of trying to explain what this future situation is that we want them to think about, and then, unpicking how they would behave and really exploring that with real people who have all of their own experiences, and really trying to take that information and then put that into a forecast that's going to give us good, robust, insightful forecasts and support Cavnue in how they're developing the corridors and thinking about things. That's a huge challenge and continues to be the key challenge in our work and when we need to explain it, because it's really the new part of the scope.
That was great, thank you.
Toni, we've talked a lot about like Cavnue's projects being new and something that people have to imagine conceptually because it doesn't exist yet, right? Would you say that element of what you just described about helping people picture something that doesn't exist is present in most surveys?
It's normally the reason we at Steer, looking at investments, do surveys. It's always when there's something new that you can't look at how someone behaved because you don't have that insight. That's when we know we need to do a survey, basically, because there's no other way of knowing how people are going to behave. You can guess, but then you miss all of those nuances that I was talking about. The whole process of going through the survey helps you to really think what is important to people.
Yeah, we've talked a lot about what like the first surveys for managed lanes looked like in the US when people couldn't imagine being able to pay to go somewhere faster next to people who weren't paying, sitting in traffic. So this is something that the industry continuously grapples with. So there's some things, I think Toni, having done so many unique projects, the right person to be doing this, because there are certainly learnings that we know you bring into our project. And then, of course, there are things that are new and hopefully exciting. They're exciting for us, hopefully exciting to study.
But yeah, no, definitely new. And I think that's what I meant with there's just every time you do surveys, you learn something different. Yeah, with the managed lanes, it was all about the fact that people just can't. Still, nobody believes how much someone would be willing to pay just to save a few minutes on that given day. It's a very difficult thing to pitch someone in a survey, but now in all of the express lanes across the US, we see that behavior. I don't think still we could design a survey kit that would really get at that. We refined it, but yeah, well, now we have the real information. We don't need the survey. Similarly with high-speed rail lines, I think that's the other challenge in the US is really understanding how people will behave when that transit option is more like a flight and like an air option rather than the typical transit services that people might be familiar with, and really trying to get at that and breaking down some of those biases that maybe people have inherent.
And I think in all of these, like, context really matters, right? Like, I don't know, I've described bringing my son to his pediatrician and driving home, and he's like screaming in the back seat, and I would pay any amount of money to get home like 3 minutes faster with a crying baby in the car, you know? Of course, that's different on a different day. And so surveys, I think, are really valuable as an initial kind of check on how people are thinking about things. And then we have to weave in known things about the context in which people drive and travel today. And so that's where some of these other learnings, like Toni said, from high-speed rail, Hyperloop, managed lanes, I think are really valuable. And it's been a good challenge to work with Steer on.
Thank you. I guess my last question before we move on to the final section is, driving is such like a personal thing that people often do alone. How does that play into the kind of like info gathering we've been talking about?
Yeah, I mean, everyone's driving experience is different. I mean, in the case of CAV corridors, right? Like, some people are really excited about new technology coming onto vehicles, and some people don't want it. Like, some people don't want it at all. And so I think one thing that's great about the approach that Steer did for this project was the focus groups and the survey we did, because you could kind of get a little more into people's heads with the focus groups. Gives color to the responses you're getting later about, like, you know, if people always want to use the lane no matter what the situation is, or never want to use the lane no matter what the situation is, you start to understand why. And what I think is really interesting about this type of space with connected and automated vehicles is thinking about, if barriers exist today, will they exist tomorrow, or will they exist in 5 years and 10 years? But yeah, being able to understand what's driving some of people's perceptions or value, I think, is really important for these types of projects.
That's great. Thank you. Looking ahead to a wider US rollout, obviously we're starting in Michigan, but hopefully next stop, the world. What will US highways look like and feel like in a decade?
So we envision smart roads and CAV corridors being deployed on critical corridors which face outsized challenges and serve majority of road users. So on these corridors, vehicle and roadway technologies will integrate seamlessly. Travelers and operators will be alerted immediately of emerging roadway risks with lane level precision. And those insights will lead to predictive safety operations and maintenance actions that maximize roadway capacity, reduce congestion, maintain travel time reliability, reduce crashes, and give drivers time back.
Great. And then I guess Steer will be there the whole way, right, Toni?
Yeah, for sure. And I think, I mean, as always with these projects, doing the first one is a big learning for everyone, and you really think things through. Once you can then take the learnings from one application and apply it somewhere else, you start really, you know, getting some momentum, knowing what we can take, what we want to improve on, what we might need more information on. So yeah, I think the first one is fun, but yeah, the next few become easier, and we're having more of an established approach. So I think, yeah, that makes the studies better.
That was great. Thank you so much. I learned a lot. Thanks very much for joining us, Megan. And thanks to you, Toni, as well.
Thanks, guys. And thanks, Megan, for your time today and talking all about CAV corridors. I learned quite a lot as well, actually.
Well, thank you for having me.